Welcome back to Chapter 2, Linear and Quadratic Functions. Today, we're going to take a look at inequalities. Now, an inequality is like an equation, but instead of saying that the two sides are equal, we might be saying that one side is larger or smaller than the other, or potentially allowing them to also be equal. In order to get a sense of what we're going to do today, it will be best for us to start by taking a look at the idea with a graph. Supposing that we have these two functions, let's say f of x and g of x. And I would like to figure out where is f of x greater than g of x. Well, in order to determine this, I will notice that this is the case on two places, from here to here, and then from here onwards. If I label these x values as a, b, and c, then I would say that this is true on the interval from a to b and the interval from c to infinity. Notice further that in each of these cases, I am using parentheses rather than hard brackets because at the places a and b and c, the two functions are equal. Thus, f is not greater than g, it is exactly equal. The other thing we'll pay attention to is that at a, b, and c, these functions are equal. In terms of just graphing on the number line, what I've got is this piece and this piece. So in other words, what I need to be able to do in order to solve inequalities is just one more step that I need to be able to do to solve regular equations. You first will want to set the two pieces equal to each other and solve, and then once you're done, you'll just have to look in between each piece to see whether it's greater or less. If the functions are continuous, which in a very colloquial sense means you are able to draw it without picking up your pencil from the paper, then there's no possible way that your function can change from being above the other one to below the other one unless they cross. And the place where they cross, well, that's where they're equal. So all we need to do to solve this kind of problem is we need to set the two functions equal, plug in points in between to fill out the number line, which we'll sometimes call a sign diagram if it would be equal to 0. And then we can simply use interval notation to describe the appropriate regions. Let's go through a couple of examples here. We'll start off with x minus 1 is greater than 3. The first thing that I'm going to do here is I'm going to solve x minus 1, the absolute value, equal to 3. Recall from the absolute value section that I will end up having two solutions here. X minus 1 equals 3, giving me x equals 4. And also x minus 1 is equal to negative 3, which gives me x is equal to negative 2. I will need to put both of these things on a number line. Negative 2 and 4. Now, one thing that you can do to make this part less ambiguous is you can set the piece greater than or equal to 0, or less than 0, or less than or equal to 0, whatever the sign is. So x minus 1 is minus 3, going to be greater than 0. X minus 1 is greater than 0, and I will plug in a point in between. I call these test values. I will need to pick a point in the middle here, and a point over here, and a point over here. Each of these points represents the three possible regions that could be greater or less than. You can pick any number. Pick one that will be easy to plug in, usually integers. For example, I might just pick negative 3, 0, and 5. Plugging in negative 3, I will get negative 3 minus 1 minus 3. So that gives me absolute value of negative 4, which will be 4 minus 3. 1 is greater than 0. That's a positive number. I will do the same thing for the middle piece. and for the right piece. And again, it did not matter exactly what values I picked, as long as the values I picked were within the region. I picked something before -2, something after 4, and something in between. This gave me a positive, negative, and then another positive region. That means that since I'm looking for the thing to be greater than 0, I'm looking for the positive pieces as my answers. So this interval from -infinity to -2, and this interval from 4 to infinity are in my answer. I'll simply need to union them together. Thus, my final answer is that x is in the interval from -infinity to -2, unioned with 4 to infinity. Both times I'm using parentheses on my intervals because the sign is simply greater than. If it was greater than or equal to, then the only difference would be that I would have hard brackets in my intervals because -2 and 4 would be okay. Let's do some more examples. Another example with absolute values. Recall that for this time, we'll again need to do a plus or minus. So let's go ahead and set up the two pieces first for the equals. X minus 1 is equal to x plus 4 over 2. And x plus 4, x minus 1 is equal to negative x plus 4 over 2. This gives me two values. -2/3 and 6 are going to be our answers here. Once again, we'll put these numbers on our number line. I'm not putting my number line to scale. I don't care. I just need to have regions. Once again, I will take the top equation and I will isolate 0. So I'll have x plus 1 minus x plus 4 over 2. You don't have to do it this way. I like doing it this way because it allows me to simply plug into one piece and just check whether it's positive or negative, rather than having to check both pieces and compare. But if it's easier for you to check both pieces and compare, by all means, go for it. You'll just have to find a good way to notate that on the number line. Let's plug in each of the three test values, which we have to select here. I'm going to choose -1, 0, and 7. But again, you could choose anything as long as it's in the correct interval. -1 will give me, let's see, a negative value. If I plug in 0, I got another negative value. And then if I plugged in 7, I get 5 over 2, which is a positive value. So in this case, I got negative, negative, and positive again. Therefore, what I've got is I've got 2/3 as a solution, and I've got the region over here as a solution from 6 to infinity. I want to double check this first piece because I think that this negative 2/3 is not correct. Let's double check this first part and make certain. So looking over here, if I were to multiply both by -1, that looks good. Multiply by 2 looks okay. Then I needed to subtract 2 from both sides and subtract x from both sides and divide by -3. This looks okay. Double checking in the original. Negative 2/3 plus 1 will be 1/3 is equal to negative 2/3 plus 4 over 2. So that will be 12 10/3 6. What did I do wrong? So a lot of times people will ask me, so here's what's going on. I believe that I've made a mistake in this second piece. The reason I think I've made a mistake is because I got a negative followed by a negative. And graphically what this would mean is that while the functions touch at one point, they don't cross, they just bounce off each other. But both sides of this equation, one side is a v and one side is a line. There isn't really a good place for the functions to bounce off each other, so I'm thinking that I've made a mistake here. I'm unable to find mistakes. So what a lot of people suggest, what I suggest that you do when you're unable to find your mistake in a problem like this is go completely to a new page and try again. This way you won't follow your previous error. I'm also going to be more detailed with my work. So let's go ahead and do that. I will need to have x plus 1 is equal to negative x plus 4 over 2. Let's first double check, make sure I've copied this correctly. X plus 1 and then x plus 4 over 2 looks good to me. And then I will need to make sure that I am good here. So, let's go ahead and solve. I will need to multiply both sides by -1. This will give me negative x minus 1 is equal to x plus 4 over 2. Then multiplying by 2, negative 2x minus 2 equal to x plus 4. Negative 3x is equal to 6. X is equal to -2. There we go. So I see that I got a different answer this time. I can go back and figure out where my mistake was now. So looking here, I see that the difference was this step. Last time I got 2 on this side, but this time I got 6. And I can trace back and say, oh wait, look what I did wrong here. This minus x plus 1. Oh, I copied the problem down wrong incorrectly. This should have been an x plus 1. So it was something as simple as that, copying it down wrong, but by going and doing the problem completely newly on a new page, I was able to more easily find the mistake. I should probably also do the other part again as well. In this case, when I make this x plus 1, that means that I have 2x plus 2 here, and when I solve, this is x is equal to 2. That means that I'm changing my number line over here. So instead, I will have -2 and 2. My test values of 0 and 7 still apply, but -1 will be no good. I'll have to switch that out. Maybe I'll pick -3. I thought about re-recording the video as I realized I made this mistake, but I decided to keep it in because I want to show you my thought process when I've made a mistake. I think it's very valuable to understand how you can go about when you think that you might have made a mistake, but you're not sure where to find it, what kinds of steps to make. So I'll have to go back and change this -3 because that old test value of 1 was no good. So we'll cross it out and we'll do that last one again. For -3, plugging this in, x plus 1 minus x plus 4 over 2 will give me -2 absolute value minus -3 plus 4 over 2. 2 minus 1/2 is 3/2, which is greater than 0. That gives me a positive. That makes more sense that I would be alternating here. We can go ahead, therefore, and determine that the answer is going to be -∞ to -2, unioned with 2 to infinity. Notice this time that I am using my hard brackets on these two endpoints. because my original sign was a greater than or equal to. So this time, -2 and 2 is where the two parts are equal, and I do want to include them, as opposed to last time where I did not want to include them. This time, I've got an example with a quadratic piece. The approach is going to be exactly the same. We'll set it equal to 0 and solve, and then we'll set up our sign diagram. 2x squared plus x minus 3 is less than or equal to 0. There's lots of ways that we can solve this piece. I'm going to choose to factor. Factoring on this side, I will have 2x and x. I need numbers that multiply to make -6 and add to make 1. I think that -2 and 3 will work. That seems like it will be pretty good. So that means that I'm going to have 2x minus 3, x plus 1, and let's double check here. 2x squared minus 3x plus 2x. Nope, that's not going to work correctly. Let's see if switching this gets the job done. 2x minus 1 and plus 3. That will be 2x squared plus 6x. Nope, that won't work. Let's switch it one more time. So I will need to get, let's try 2x plus 3 and x minus 1. 2x squared minus 2x plus 3x. That one works out okay. So I was able to factor after some trial and error. You can always do it out the long way if you need to. But for once this simple, I like doing trial and error. Regardless, I'll continue the problem, setting it equal to 0. I'll break it up into my two pieces. So 2x plus 3 is equal to 0, which means that x will be equal to -3 halves, and x minus 1 is equal to 0, which means that x will be equal to 1. Again, I'll put it on my number line. -3 halves and 1 come out, which means I'm going to pick test values, let's say -2, 0, and 2. Plugging in these values to my piece. I will obtain for -2, so that will be -4 plus 3 times -3, -1, -3, will end up being positive. For 0, this one is easy. 3 times -1, -3, negative. And for 2, I will have 4 plus 3, 7, times 2 minus 1, 1, positive. My intervals then will be -infinity to -3 halves. Whoops, I don't want to include that one. Double checking my sign, less than or equal to. That means that negative is going to be my correct region. So I want -3 halves up to 1. I'm using hard brackets because the sign includes equal, so I want to include both endpoints. Let's do one more example. Word problem this time. The height h in feet of a model rocket above the ground, t seconds after liftoff, is given by this equation. H of t is -5t squared plus 100t, and it's valid when t is between 0 and 20. I would like to know what times the rocket is at least 250 feet off the ground. So really what I'm asking myself is, where is h of t greater than or equal to 250? -5t squared plus 100t is greater than or equal to 250, and suddenly I've got a problem just like the last ones. We're going to set everything on one side, and I'm also going to divide by -5 here to make the problem easier to solve by hand. T squared minus 2t minus, plus, and then 250 over 5 will end up being 50, greater than or equal to 0. Now this one I'm not sure I'm going to be able to factor because 50 has factors of either 10 and 5 or 2 and 25 would be our pairs, or 1 and 50. But none of those are going to be separated by 2. So we're going to have to use the quadratic formula to solve this one. or we're going to have to complete the square. Let's do completing the square, because I'm imagining that that is the one that is less familiar to most people here. So it will be good to see an example of that. So with that, I will have t squared minus 2t plus, I'll need to figure out what to add. In this case, my b is negative 2. Negative 2 over 2 squared is equal to 1. So I will add and subtract 1 here. That will give me t minus 1 squared minus 49 is equal to 0. Plus 49, excuse me. That means that t minus 1 squared will be negative 49. We drop a negative somewhere? I think we must have. Because this will, of course, have no solution because I'm about to try to take the square root of a negative number. So let's check again real fast the first bits here. Once again, I'm going to want to bring myself to, I see what it is. I needed to put 100 here, plus 100t. That means that this will be 20t, this will be 20t. That means that I have 20 over 2, which is 10 squared 100. So 100 is what I need to add and subtract. 100, 100. So that means that this will be equal to t minus 10 squared minus 50, and that means that t minus 10 squared is equal to 50. That makes more sense. Then I can go ahead and take the square root, so t minus 10 will be equal to plus or minus the square root of 50, which means t is equal to 10 plus or minus the square root of 50. Now, if this was just a math problem, I would be happy with that answer, but as it's a word problem, I'd like to be able to interpret that answer. So we'll need to be able to plug that into a calculator. So if I take the square root of 50, and I will need to either add or subtract that from 10. Adding that to 10 will give me 17 point, it says 2 decimal places, 0.7, and 2.93. So I would say, since this is a word problem, I want a word answer. The rocket is at least 250 feet off the ground from 2.93 seconds to 17.07 seconds. And there we go. That's the end of chapter 2. I'll see you guys next time.